Hello everyone, welcome to numerical modeling. Today we are going to perform an experiment on groundwater seepage analysis using finite element method. For that we are using RS2 software. So before going to that, just we have to know the fun definition of the water seepage, groundwater seepage. So generally, this term is frequently used in geomechanics or rock mechanics or soil mechanics. So what is seepage of water? Say water seepage. So generally, it is the movement of water through soil or rock pores under the influence of hydraulic gradients. So this is a flow of water. Uh, yes. So why should we study water seepage? Why it is so important? Because it plays a crucial role in the stability and strength and deformation of the rock structures, such as slopes, tunnels, dams, and the other rock excavations. So for that, to analyze water seepage, I will take pre-existing data which are already in the tutorials. Okay, for that, so we have to go for the files. Here you can see file, then click on file, scroll down. Here you can see recent folders, then click on tutorial folders. Then here you can see groundwater seepage. This double click on that, then go for finite element groundwater seepage initially. So double click on that, then this is the pre-existed model. So already everything is there, the material properties. So then we have to analyze by applying some tools. Then we can analyze the water seepage. So for that, we have to go for already the material properties are assigned, so I am not going to explain those material properties, how to add material properties. For that, let's go for loading. We are analyzing water seepage now, that's it. For that, loading, here you can see ponded water loads and add ponded water load. Then we have to click on that. You can here see total head. So what is total head? So we have to learn that one. And as before going to that, what is ponded water load? We need the definition. Simply the ponded water load nothing but the pressure exerted by the water externally. That is not known as ponded water pressure. That external water nothing but some through the ponds or reservoirs or some other accumulated water by exerted on the slope. That is known as ponded water pressure. That is the pressure exerted by the water externally. So just I will give some extra information like pore water pressure. What is pore water pressure? That is nothing but the pressure exerted by the water which are in the pores. So the pressure is internally nothing but that is pore water pressure. Externally nothing but pond water load. So this is the difference between that. Okay. So we have to add how much that pressure is adding. So that is the total head, that is the column of the water, that is known as total head. So I will use 26 meters of total head. Then you have type on 26 here, then click on OK. It will show one plus red symbol. Then you have to click on select that edge or corner vertex of the slope. Then you have to end on the slope face. Okay, so I have given that the pressure that 0.00 megapascal or mega newtons per meter square. This is added the load. Then again we have to add some field stress for heat. That is there is a constant and gravity. So it's better to use gravity. Then use actual ground surface. Click on that and select that one, and after that click on OK. We have accomplished the field stress. Then we have to add meshing. I already explained what is meshing, elements, and what is node. These are all the basic concepts are explained in earlier videos. Okay, then go for mesh and here you can see mesh setup, and then click on discretize, and you can here see mesh and click on mesh. Okay, this is the way to apply mesh. Then we have to apply the boundaries. So generally we have two types of boundaries. One is hydraulic boundaries and another one is mechanical boundaries. Okay, just I will give simple definition for it. Then let's okay. Those definitions are like hydraulic boundaries, which is defined as how water behaves at boundaries. Okay, and the mechanical boundaries which deals with the displacement or the stress uh, at the boundaries. Okay, the displacement and stress behave at the boundaries, that is mechanical boundaries. Again, these hydraulic boundaries are subdivided into fixed head boundary, nothing but constant water pressure, no flow boundary, there is no seepage, and seepage phase, water can exist freely at atmospheric pressure, that is nothing but seepage phase, and flux boundary, this is the last one, that is fixed rate of water inflow or outflow, that is flow boundary. So this is these four types are from hydraulic boundaries. So let's apply hydraulic boundaries here. Then we can apply mechanical boundaries. That is applying, we are applying both. This so we can call as hydromechanical boundaries. So let's apply to apply the hydraulic boundaries. Click on the groundwater. Then you can here see set boundary conditions. Click on that. Then we have to select the total head. That is, we already applied total head, so this is 26. Then type on 26 here, and just I given 26 here. Then click on here the slope and the base of the slope, then apply. So this is the way to apply the total head here. Then in the front side, and I will add the back side, that is 31.8 the total head. Then just we can click on the back side of the slope, then click on apply. So it's applied. This is the front side and this is the back side. So these surface is exposed to the rainfall and atmosphere. So I don't want to consider those things, just I will leave it as a constant. So there is no pore pressure, there is no nothing is there. For that here you can see one P is equal to 0 and Q is equal to 0. Okay, Q is nothing. What is Q here? P is nothing. P is equal to 0 pressure. Okay, Q is nothing but nodal flow rate is 0, everything is 0 here. Okay, then select here and then apply. Okay, we have applied hydraulic boundaries. Then go for mechanical boundaries. For that, just click on displacements, then click on free. Okay, just for that, so actually I am recording the video, there is a problem to see this box, so then I will close it and I will apply like this. Just apply this one. Okay, nodal segments, just unable to see this. I will add only so just go for displacements, then click on free. It's showing, so directly we can use those things, but just select this one, and remove this top surface, because there is no any restricted boundary or roller boundary here, because it is already exposed to the surface. Then apply, it's removed. Okay, then here here you should apply that one node. Okay, here there is a node, no problem at all. Here is a node, just we have one node here. For that, here I can select from here, but I am recording, but there's a problem to select. That's why this complicated process I am choosing. Just select, first of all here we can select as a node, then select as a and apply. Just again just click here, then apply. Okay, so we have done everything, apply and close. What we have done, we add pond water load, then we applied mesh, we discussed, and we have added hydraulic boundaries and mechanical boundaries. Everything is completed, and already there is a material properties for the slope stability, this slope. So then last step is compute and interpretation and analyzing the data by the output. So then have a look, just groundwater. Okay, it's well defined, no problem with that groundwater. Okay, then come to displacements again. Okay, everything is fine. Then click apply and close. Then go for analysis, and here you can see compute, then click on compute and click on yes. It's accomplished fast because it's only one slope. Then directly we can click here interpret for a standardized methods, and go for a interpret from then click here interpret. So this is the output, but one thing you have to, the ultimate agenda is to study the seepage of water. So for that we have to add one section to know the water head. So again go for groundwater. Here you can see add discharge section. Okay, then add one discharge section here. Again go for groundwater and add discharge section. Again here add another discharge section. Sorry. Okay, no problem with that. Done. Or if I want to delete it, just delete, because okay. If you want to know the water flow in different sections, then we can add a different n number of discharge sections. That is our wish. Okay, I add only 3 sections. Then compute and interpret. This is the actual model. So here you can see the flow rate 7.9492, E nothing but 10 to the power minus 8 meter cube per second, like that 7.912, and gradually the flow rate is decreasing from this back from boundary to this front. So just if you want to know the the flow vectors, the water flow, just right click here. Here you can see display options, then stress boundaries, boundary support, and here you can see groundwater. Then select pond water and water table. So this is water table which indicates water table. Then flow vectors. Okay. Click on the flow vectors. You can see the water flow. Okay. This is from this section. You can analyze the flow of water. Okay. This is the model. Here you can see, you can select seepage, this pore water pressure, this minus 0.05, this is the data of the pore water pressure. Then again go seepage, and this is a pressure head and total head. Here we applied 31.80. Okay, this is 31.80, and this blue color indicator 26. Okay, this one, this is the total head. And go for seepage, this pressure head. Okay, the maximum pressure is 11.80. Okay, this is the about water seepage analysis. But there is the another method is there. Different tools are to apply to analyze the water seepage. These will be continued in the next part. We will meet in next part. Okay, thank you so much.